Differentiation of exponential functions. Exponent is another word for index or power. A function, such as y equals 2 to the power of x, in which the variable occurs as an index, is called an exponential function. The function y equals e to the power of x is called the exponential function or natural exponential function. E is an irrational constant whose value is 2.71828 correct to 6 significant figures. E to the power of x is the only basic function which is its own derivative. That is, if y equals e to the power of x, then dy dx, so the derivative, is also equal to e to the power of x. Note, the positive number e behaves just like other positive numbers such as 2 or 5. E to the power of x obeys all the usual laws of indices or exponents. Using the chain rule, suppose u is a function of x. If y equals e to the power of u, then dy dx, the derivative, is e to the power u multiplied by du dx, so multiplied by the derivative of the index. Find dy dx, the derivative, if y is equal to e to the power of x squared minus 3x. So y is equal to e to the power of x squared minus 3x. So dy dx, the derivative, will be e to the power of x squared minus 3x multiplied by 2x minus 3. So we got this from our chain rule formula. So we just basically write down what we're given. So e to the power of u is e to the power of x squared minus 3x. And then we get du dx, which is the derivative of the index. So the derivative of x squared is 2x, the derivative of minus 3x is minus 3. And then we just multiply, so we stick them together. So we end up with 2x minus 3 times e to the power of x squared minus 3x. Find dy dx if y is equal to 2 over e to the power of 3x. So the first thing we want to do is rewrite this. So we don't want a fraction. So we're going to change the fraction into, we're going to have a negative index. So the 2, which is the numerator, comes down in front. Because it's 2 over, we end up with minus, and e to the power of 3x becomes e to the power of minus 3x. So we're using one of our laws of indices to rewrite this fraction as a negative power. Now we can differentiate. So dy dx is going to be 2e to the power minus 3x. So that's going to be the e to the u using the chain rule. So we basically just write that down as it is. And then we need to get du dx, which is the derivative of the index. So the derivative of minus 3x is minus 3. And then we just multiply. So the numbers get multiplied. So 2 times minus 3 ends up giving us minus 6. And then we just stick e to the power of minus 3x onto the minus 6. So we've minus 6 e to the power of minus 3x. But then we're going to use our laws of indices to just rewrite this. Because we don't want a negative index, we want a fraction. So we're going to go back to the original format that we were given. So we end up with a minus in front. The 6 becomes the numerator. And e to the power of minus 3x becomes e to the power of positive 3x. And we have our line in between separating them as a fraction. So we end up with minus 6 over e to the power 3x. Note, the quotient rule could also be used in parts 2 and parts 4. So this is part 2 here. So we could have used the quotient rule. So our u would have been 2, our v would have been e to the power 3x, and we would have subbed it into our quotient rule formula, which is v du dx minus u dv dx all over v squared. But it just would have taken a bit of more time. Part 3, y equals e to the power of sine 2x. So again, we use our chain rule formula. So we just write down the e to the u, which in this case is e to the power of sine 2x. So we just write that down as it is. And then we differentiate the u. So we differentiate the index. So the index is sine 2x. So to differentiate this, we're going to have to use the chain rule. So I know we're already using the chain rule, but we're going to use the chain rule inside of the chain rule to differentiate sine 2x. So the derivative of sine is going to be cos. So we have cos, we keep the angle, we keep the 2x, and we multiply that by the derivative of the inside. So the derivative of 2x is 2. So this is our outside, this is our inside. So we're using the chain rule inside of the chain rule. And then we just simplify. So the 2 comes down in front. That's multiplied by cos 2x. Make sure that you don't multiply the 2 and the 2x because they're totally different things. The 2x is part of the angle cos. So we would never say 2 by 2 is 4x. We keep them separate. And then we just stick on the e to the power of sine 2x. And lastly, y equals x over e to the power 2x. So we're going to rewrite this because we don't want a fraction. So it's going to be the x comes in front, so the numerator comes in front, and the divide gives us a minus, and e to the power 2x is now e to the power of minus 2x. So now we have x multiplied by e to the power of minus 2x. So we're going to use the product rule, which is dy dx equals u dv dx plus v du dx. So the u is going to be x, the v is going to be e to the power of minus 2x. So dy dx, the derivative will be u, which is x with brackets, multiplied by dv dx, so the derivative of e to the power minus 2x, which again we'll use the chain rule. So we'll have e to the power of minus 2x, we just keep that as it is. We multiply that by the derivative of the index, the derivative of minus 2x is minus 2. Then we have plus. Then we have v, which is e to the power minus 2x, multiplied by du dx, the derivative of u, so the derivative of x is just 1. Then we simplify. So the minus 2 comes in front, then the x, and then we stick on e to the power minus 2x. So we've minus 2x e to the power minus 2x. Then we simplify over here. So e to the power of minus 2x times 1 is just e to the power of minus 2x. Next we can factorize. So we can see that e to the power of minus 2x is the highest common factor. So that divides into minus 2x e to the power minus 2x e to the power of minus 2x, leaving us with minus 2x. So we see that the e to the power minus 2x just cancels out. So we're left with minus 2x. And then e to the power of 2x into e to the power of 2x leaves us with 1. So you could have had those the other way around if you wanted. And then to finish it off, we're just going to rewrite it as a fraction because we don't want a negative index. So we have e to the power of minus 2x multiplied by 1 minus 2x. So the minus gives us a fraction. The 1 minus 2x is our numerator. And e to the power of minus 2x becomes e to the power positive 2x in our denominator. Note the quotient rule could have also been used in parts 2 and 4. So this was part 4. So we started off with a fraction. So this could have been the u, this could have been the v, and we could have used the quotient rule. Just would have taken a little bit longer. If y equals x e to the power of minus x, show that d squared y dx squared plus 2 dy dx plus y is equal to 0. Okay, so y is equal to x times e to the power of minus x. So since they're multiplied, we are going to be using our product rule, which is u dv dx plus v du dx, where the u is x and the v is e to the power of minus x. So dy dx, the derivative is u, which is just x with brackets, multiplied by dv dx, so the derivative of v. So the derivative of e to the power minus x, well, we use the chain rule, so we just write down e to the power of minus x. We multiply it by the derivative of the index. The index is minus x, the derivative of that is minus 1. So we use the chain rule here inside the product rule. Then we have plus, then v, which is e to the power of minus x, multiplied by du dx, the derivative of u, well, u is x, so the derivative of x is just 1. Then we simplify. So we have x times e to the power of minus x times minus 1. So minus 1 times x is minus x, and then we just stick on the e to the power of minus x. And then e to the power of minus x times 1 is e to the power of minus x. And we notice that we have e to the power of minus x common to both, so we factorize. So e to the power of minus x into e to the power of minus x goes once. And e to the power of minus x into minus x e to the power of minus x leaves us with minus x. So you could have had these the other way around if you wanted. So we've worked out dy dx which we're going to need up here. So next we need to work out d squared y dx squared. So we're going to have to then differentiate this. So if dy dx, which we worked out in the last slide, is equal to e to the power of minus x times 1 minus x, then d squared y dx squared, so this is the second derivative. So since these two things are stuck together, they're multiplied, we're going to have to use the product rule again, which is u dv dx plus v du dx, where u is e to the power minus x and v is 1 minus x. So u is e to the power minus x, so we just write that down with brackets. We multiply that by dv dx, the derivative of v, well, the derivative of 1 is 0, the derivative of minus x is minus 1, so we have minus 1 in brackets. Then we have a plus. Then we have v, which is 1 minus x with brackets, and that then we want to multiply that by the derivative of u, so du dx. So u is e to the power minus x, so we're going to use the chain rule. So we write down e to the power of minus x, and we multiply it by the derivative of the index. The derivative of minus x is minus 1. So now we simplify. E to the power of minus x times minus 1 is minus e to the power minus x. And then we're just going to bring down 1 minus x. And e to the power of minus x multiplied by minus 1 is minus e to the power minus x. Then again we bring down minus e to the power minus x. And next we're going to multiply these brackets. So 1 multiplied by minus e to the power minus x is minus e to the power minus x. And minus x multiplied by minus e to the power minus x is going to be plus x e to the power minus x. Then we simplify. So minus e to the power minus x is really minus 1 e to the power minus x, as is this one. So minus 1 is minus 2. So we have minus 2 e to the power of minus x. And then we just bring down the x e to the power of minus x. Next we factorize. So e to the power of minus x is common to both. So e to the power of minus x divides into minus 2 e to the power of minus x, leaving us with minus 2. And e to the power of minus x divides into x e to the power of minus x, leaving us with x. So again, you could have had these the other way around. So now we've just worked out d squared y dx squared, which is the second derivative, which we need here. So now all we have to do is substitute into this formula. So d squared y dx squared, we worked out in the previous slide, to be e to the power of minus x times x minus 2. We're going to add that to 2 times dy dx, and dy dx we worked out in the 2 slides ago to be e to the power of minus x times 1 minus x. And then we're going to add that onto y, which was given in the question, which is x e to the power of minus x. Next we multiply out the brackets. E to the power minus x times x is x e to the power of minus x. And e to the power minus x times minus 2 is minus 2 e to the power minus x. Then 2 times e to the power minus x times 1 is 2 e to the power minus x. And then 2 times e to the power of minus x times minus x is minus 2x e to the power of minus x. And then we just bring down the e to the power of minus x. Next we factorize. So e to the power of minus x is common to all terms. So e to the power of minus x divides into x e to the power of minus x, leaving us with x. E to the power of minus x divides into minus 2 e to the power of minus x, leaving us with minus 2. E to the power of minus x divides into 2 e to the power of minus x, leaving us with 2. E to the power of minus x divides into minus 2x e to the power of minus x, leaving us with minus 2x. And e to the power of minus x divides into x e to the power of minus x, leaving us with x. Then we simplify. So x and minus 2x and x will all cancel. So that's 2x take away 2x, which will cancel. And minus 2 plus 2 will cancel. So we're left with e to the power of minus x multiplied by 0. And anything multiplied by 0 is 0. So we end up with 0, which is what we were asked to do.